Hi, and welcome back to class of Product Development and Entrepreneurship. I am Hitesh Raiyani, Assistant Professor at LJ Institute of Engineering and Technology. This is lecture 13, Guidelines for Design for Manufacturing and Assemblies. Learning outcomes of these lectures is to learn the guidelines for design for manufacturing and assemblies. So in previous lectures, we learned the design for manufacturing, and we know the design for manufacturing is the design of components or any product by considering the manufacturing aspect. Now in these lectures, we learn the design for manufacturing and assembly guidelines. So when we have to design any components or any products according to the design for manufacturing and assemblies, and which are the rules, which are the guidelines we have to follow, that we learn in these lectures. So in previous lectures we learned the design for manufacturing and design for assembly are the integrated process, and here I also shows the diagrams in design for manufacturing and assemblies, and you can see that both are the integrated process, and here in right side there are design for manufacturing and assembly process. Above there are DFA and the guide DF for design for manufacturing and assemblies. We have to minimize the number of parts, optimizations of assemblies. And for design for manufacturing, we have to choose the best process. We have to choose the best material, optimize the process. So all these things we have to do so that the manufacturing cost of products is reducing. So to design the component based on the manufacturing, design for manufacturing and design for assemblies, the goal is to reduce the manufacturing and assembly cost, and also easy of manufacturing product and easy of product assembly. So these are the main aspect while we have to do design of any components with respect to the design for manufacturing and design for assemblies. So to reduce the manufacturing cost, in previous lectures we learned that manufacturing cost is divided into three elements. First is the component cost, second is the assembly cost, and third is the overhead cost. So here the component I shows the element of manufacturing cost of product. So these are the manufacturing cost elements, and our aim is to reduce the manufacturing cost as well as the assembly cost. So what are the guidelines we have to follow so that we have to reduce the manufacturing cost, and also we have to easily fabricate any product. So let's we start the guidelines which have to follow for the design for manufacturing and assemblies. So first guidelines of for design for manufacturing and assembly is the reducing the total number of parts. As we know that if any product has more number of parts, then the manufacturing cost and assembly as well as the assembly cost is increases, because as number of parts is increased, the assembly time is more requirement and assembly becomes complicated. So here we have to first consider the reducing guidelines is reduce the total number of parts. So as the number of parts is reduced, also the manufacturing process is become simple, and at the time of manufacturing process or to manufacture the product is also required the less. So ultimately the manufacturing cost is reducing. Now question is how to reduce the number of parts. So for examples, if there are any products that have the 100 number of parts and we have to reduce these parts of the product, so how to reduce? So there are the rules that will be considered while we reduce the number of parts. For example, so the parts make combinations. We have to make the combinations of parts, 2 to 3 parts we have to combine, which has same materials or which have no relative motions between each other. So we have to reduce the parts by eliminate the component. And to eliminate the component, we have to consider that whether there are no relative motions between the parts, whether we have to consider that all the parts are made on same materials, or those parts which is make the complexity of the assemblies, that we have to eliminate to reduce the number of parts. Second guidelines for design for manufacturing is to develop a modular design. So use of modules in product designs ultimately reducing the manufacturing activities, and that will be reducing the manufacturing cost. So it simplifies the manufacturing activities like inspections, testing, assemblies, maintenance and service, etc. So it will be directly reducing the manufacturing cost. So next is the use of standard component. So as we seen in the manufacturing cost, there are the first element is the element cost, and there are two types of element. First is the standard component, and second is the custom component. So we have to use the in our design the standard component, so we can easily use in our product. So a standard component is easily available in the market, and if we use the custom component in our product design, then we have to manufacture in our own workshop. So it will be required the more times, and also the to make the customs we need the process, or we need the equipments, and we have to time to make the custom components. So it will be increase the manufacturing cost and increase the product development or product manufacturing times. So we have to use the standard component, which is less expensive as compared to the custom components, and easily available in market, so we can reduce the lead times of the particular components. So these are the guidelines for the design for manufacturing and assemblies. So next guidelines is the design part to be multifunctional. So we have to design the components. At that times we have to consider the guidelines that these components has to be multifunctional. So it can be used in multi-functional. So for example, multifunctional parts reduce the total number of parts, because the same components act as multifunctional. So as for example, the part which is used for the electric conductors, and also it is used for the supporting as a structure member. So these are the multifunctional guidelines we have to follow while we doing the design for manufacturing and assemblies. Now next guidelines is design parts for the multi-use. So as we have to use the multifunctional component, we also consider the parts for the multi-use. So in manufacturing frame, if you think different product can share the parts that have been designed for the multi-use. So to you identify for that, we have to identify the multi-use components. So based on the parts that are used commonly in all products, we have to first identify, and because based on the common activities or commonly used in all products, we have to create the part families, and to create the part families, we have to goal to minimize the number of categories and variations within the categories. The result is a set of standard parts family from which the multi parts are created. So from part families, which are the multi-use parts, we have to create it as on the part families. Now next is the design for easy of fabrication. So here we have to consider the design component which has easily fabricated. So select the optimum combinations between material and fabrication process to reduce the manufacturing cost. So next is the avoid the separate fastener. So when we have to design our component, we have to avoid the separate fastener, because the use of fastener increasing the manufacturing cost, and fastener should be avoided by the replacing fastener can be avoided by using the snap fits or by using the tabs, etc. And whenever the fastener to be used, that guidelines for the using the fastenering we have to follow. For example, minimize the number of fasteners, size of fasteners, or variations in fasteners we have to follow. Next is the minimize the assembly direction. So when we do the assembly of components, we have to consider that all parts are assembled with the minimum assembly direction. So all parts should be assembled from one direction, and if possible the best way is to add the parts from the above in vertical directions parallel to the gravitational direction, so assembly can easily manufacture it. So next is the minimize handling. So handling is what? Handling consists of positioning, orienting, and fixing parts or components. So when we do the design of components, we have to keep in mind that the all the components can easily handle while we doing the assemblies. So to facilitate the orientations, symmetrical parts should be used whenever possible. So if there are symmetrical parts, we can easily orient it that parts when we do the assemblies or assemblies of that particular components. So these are the guidelines which we have to follow while we'll do design for the manufacturing and assembly. So it will be reduce the assembly and manufacturing costs, and also reducing the manufacturing and assembly times. So in our next lectures we will learn the design for maintenance. Thank you.